We are going to talk about piecewise functions today. So this is section 1.4, and we want to know, how do we graph a piecewise function? So the first kind of question is, what is a piecewise function? The word kind of gives it away. It's different pieces of functions kind of just strung together. So you're going to see a list of different functions, and they all have their own domain. So it might be from negative infinity up until, some point, and then that's one graph. And then from that point to another point is another graph. And then from that third point on to infinity is another graph. So it's different pieces of different graphs strung together on in one function. And so the notation that we use is, because it's a function, we use that f of x equals, and then we open up that curly bracket, and then that's where we list out the pieces of the function. And notice we list the function first. 2x is a line, it is a graph, it is a function. And then we're using the domain of x's that are less than negative 2. Then we go to our second function, which is 4. What is f of x equals 4? What is y equals 4? That's just a horizontal line. So we're just going to be graphing a horizontal line on the domain from negative 2 less than or equal to x less than 3. And then the third function is that negative 3x minus 7 on the domain of x is greater than or equal to 3. Notice in this notation, like I said, you have the curly bracket, then you're going to list out your functions, then you're going to list out your domains. Your domains will always be written in that inequality notation. So it's not going to be interval, it's not going to be set, it's going to be in that inequality notation. That's always how you're going to write it, and that's always how you're going to see it. Okay. And typically, not every single time, but typically you will see them in order from left to right. Okay. These are all the x's less than negative 2, negative 2 to 3, and then bigger than 3. So that's reading from left to right. And that just helps us graph. Okay. So if this is the piecewise function given to us, we need to evaluate this function at certain x values. And so here we have at f of negative 4. So we need to decide which function should we be using that has the x value of negative 4. Well, negative 4 is going to fit into this domain, x's that are less than negative 2. So I'm going to use this function. I'm going to plug in this x value of negative 4. So what is 2 times negative 4? That's going to be negative 8. Okay, now we'll go to the next one, negative 2. Well, I see negative 2 here and here in those domains, but which one is including negative 2? The second one. And that second one is just a constant. There is no x, so my answer is going to be 4 no matter what. So when x is negative 2, y is 4. When x is negative 1, y is 4. When x is 0, y is 4. When x is 1/2, y is 4. All the way up to that 3. Okay? Then we have f of 0. Again, 0 is fitting into that middle domain. So again, 4. Then we have f of 3. Are we going to use the middle, or are we going to use the last? The last one, good, because that's where 3 is included. So I'm going to plug in 3 for my x value. So what is negative 3 times 3? Negative 9 minus 7. So that would be negative 16. And the last one is 5. Again, that's going to fit into that last function. I want x's that are greater than or equal to 3. 5 is greater than or equal to 3. So I plug in 5. That's going to be negative 15 minus 7, which would be a negative 22. Okay, so you're looking at this x value to determine which domain it fits into, and then plug it into that according function. Okay, now what if we have a graph? Same kind of thing. We are given this piecewise function. This is an example of what a piecewise function can look like. And notice we're doing the same thing here. We're evaluating. Okay, so I'm going to ask you f of negative 1. Well, when x is negative 1, I'm using this middle graph, and what's that y value? It's 0. What about f of 2? Well, when x is 2, my y value is 1. F of 1. Notice there's 2 points that have x as 1, but one of them is not included. It's that open circle, so we're not going to use that. We're going to use the one with the closed circle, which is also giving us a value of 1. All right, then we have f of negative 2. When x is negative 2, again, we have that closed circle, and then we have that open circle. We want to use the closed circle, so that is going to be a negative 1, and then f of 0. F of 0, x is 0, my y value is 1. So I'm just looking, I'm finding where that x value is and just listing the y value at that location. Okay, now we're going to get into actually graphing these piecewise functions. So like I said, they give us the function and then they give us the domain that it's on. There's a couple different ways that you can do this. Sometimes it might be helpful just to graph the entire function and then erase what's not in that domain. Other times it's easier to plug in values from that domain into the function. What do I mean by that? Well, the first option, like I mentioned, is graphing this entire function, 2x minus 1. That should be easy for you to graph. That has a slope of 2 and a y-intercept of negative 1. So I'm starting here, up 2 over 1, up 2 over 1, up 2 over 1, down 2 left, down 2 left. So there's that line 2x minus 1. But I only want it for the x values that are less than or equal to negative 1. So when x is negative 1, my function is starting right here. So I want everything to the left of that, meaning I don't want any of those points. Okay? So that's the first way we can do it. The second way that you can do it is actually plugging in x values from that domain. So I would say, okay, if x is less than or equal to negative 1, can I use the x value of negative 1? Yes, so I plug it in. 2 times negative 1 minus 1. Well, that would be negative 2 minus 1, which is negative 3. So when x is negative 1, my y value is negative 3. And then I could do the same thing for any other x value that's less than or equal to negative 1. So maybe I want to try negative 2. 2 times negative 2 minus 1. That would be negative 4 minus 1, which is negative 5. So when x is negative 2, negative 5. And then boom, I can make my line there. The same exact thing. Okay, so it's whatever's easier for you, and it might depend on the problem. It might depend on your personal preference. It's just up to you. Okay, the second part of this piecewise function is negative x plus 3 on the domain of x is greater than 1. So I'm going to go ahead and plug this in. So I want x is greater than 1. I can use a 1 and plug it in. I just can't put a solid dot there. I would have to put an open circle because it's not included. And that's what I'm going to do. So if I plug in 1, that would be negative 1 plus 3, which is 2. So when x is 1, my y value is 2, but it's not included. So I'm going to put an open dot there. Okay, at this point, what I can do is I can just use that slope. My slope is negative 1. So I'm here, 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 here. Okay, I know I'm going to the right because I want x is greater than 1. If it was x is less than 1, then I would have been going this way. Okay, but remember, these are functions. So even if I would have accidentally gone this way, you should have automatically, if this wasn't there, let's say you accidentally did that, there should be a red flag going off in your brain. Why? Because this is not a function. It does not pass that vertical line test. Okay, so these are piecewise functions. So we don't want it right there. So this makes sense because it does pass our vertical line test. And we could list out the domain and the range and increasing and decreasing and incorporate all those characteristics that we learned back in 1.1. And that's something that we will do in the future. Okay, moving on to the second one. So now we have f of x equals 1/2 x when x is less than 2, negative 2. We have f of x is equal to negative 1 for negative 2 less than or equal to x less than 3. And we have f of x equals negative 2x plus 3 for x is greater than or equal to 3. Like I said, you can kind of go in your own order. For example, maybe this middle one is going to be very easy for you to start with. Why? Because it's just y equals negative 1. That's just a horizontal line. So if my domain is from negative 2, that's a solid dot, it's including, all the way to that positive 3, open dot, not including, there's that middle function already done. That is f of x equals negative 1 on the domain from negative 2 less than or equal to x less than 3. Okay? So if we need to skip around, that's totally fine. I'm going to go ahead and go back up to the top. which is just 1/2 x on the domain of x is less than -2. So I can start at -2 for my x value, but wherever that y value is, I need to make sure that I'm using an open dot because it's not included. So if I plug in -2, what's 1/2 times -2? It's -1. So if I go to plot -2, -1, I'm putting an open dot there, but guess what? There's already a solid dot there. That's okay. Sometimes our graph is going to piece together where there's an open dot and then something comes in and fills in that dot. That is perfectly okay. All right, and that's exactly what happened here. We had an open dot, but over here we had a closed and then an open, and that's okay. Now, from there on, I can continue using my slope. Remember, I'm going to the left because I want those x values less than -2. So my slope is 1/2. So instead of going up 1/2, I can go down 1 left 2, down 1 left 2. And so I'm going this way. And so now you can kind of see this piecewise function being strung together. Excuse me. And then we're going to our last function, which is -2x plus 3 for the x values greater than or equal to 3. So again, I can plug in the x value of 3, and I can put a solid dot wherever that y value is. -2 times 3 plus 3, well, that would be -6 plus 3, which is -3. So when my x is 3, my y value is -3, and there is a solid dot there. From that point on, I'm going to the right, and I can use that slope of -2. So I go down to right 1, down to right 1, and piece it together there. Okay, and there's my piecewise function. Okay, if I were to ask you the domain and the range, what is your domain? It's from -infinity all the way to +infinity, and there is no break. Why? Because even when x is 3, I know there's an open circle here, but there's a closed circle here. So I am using an x value of 3 in this function. Okay, now for range, what would your range be? Your range would be from -infinity all the way up. We might think we stop here and start back up again, but we don't, because over here we are incorporating those y values. So really we're going all the way up to this y value of -1. So that would be from -infinity to -1, and we do incorporate that value. Okay, it's really good to cycle that old information into new information. Talking about characteristics of functions is something that we're going to do throughout the entire school year, guys. Okay, so domain, range, increasing, decreasing, positive, negative, those absolute maximums and minimums, okay? So this would be a really great place for you to pause the video and try some on your own. I'm going to just keep on going. So we have f of x equals x minus 2 when x is not equal to -1. And we have f of x equals 3 when x is equal to -1. So I need you to think about this first function. The domain is x cannot be -1. So what does that mean to you? That means that it can be any other number. It's every single number except for -1. So this function is going to be almost the entire single graph. Okay, so I'm going to go ahead and just plot this whole entire graph as is. I'm going to use that y-intercept of -2. I'm going to use that slope of a +1. So I'm here, here, here. I'm going to continue that pattern, and I'm going to make my entire line. Oops. Okay, but then I need to remember I cannot use x to be -1. Well, when x is -1, my function value, is right here. So I need to put an open circle there because I am not including that value. I can still make my solid line. Okay, but what about when x is 1? I'm sorry, when x is -1? What is the function value when x is -1? +3. 1, 2, 3. Just that one value. Okay, so this is a little weird. It's almost like just that one line, but we took out one of those points and just moved it to a different location. So again, is our domain from -infinity to +infinity? Yes, because every single x value is included. Is our range negative infinity to positive infinity? No, because we are not incorporating that y value. We're going from negative infinity all the way up to this -3, not including it, and then starting back up and going all the way to infinity. That would be our range. Okay. All right, next one. F of x is equal to these three pieces of the function. So I'm just going to start at the top. 1/3 x plus 2, and that's for x's less than or equal to -3. So I'm going to plug in -3, so 1/3 -3 plus 2. And can I use a solid dot there? Yes, I can. This is going to be a -1 plus 2, which is going to give me 1. So when x is -3, my y value is a +1. I can put a solid dot there because it's less than or equal to and not just less than. Okay, from that point on, I know I'm going to the left, using those x values to the left, so I can just incorporate my slope. So instead of going up 1 over to the right 3, I can go down 1 and to the left 3. And so I'm going this way. Okay. The next section is -x minus 2 for -3 less than x less than 0. When I plug in my -3, I get 3 minus 2, which is 1. Can I put an open or a closed circle there? Open. Good job, because this is just less than, not less than or equal to. Okay, so I'm going to find the point -3, -3, comma 1. Oh, I'm putting an open circle there, but there's already a closed circle. That is okay. So it's just a solid circle now. It fills in that circle. All right. And then again, from there on, I'm going all the way up until my x value is 0, and I'm going to use that slope of -1. So down, down. And then can I do this? No. It has to be an open circle here. Okay. So now I'm connecting that. Okay. And then time for the last one. X squared minus 2. Hopefully you know how to graph this from Algebra 1. That is just a basic parabola that has been shifted down 2 units. So on the coordinate plane, instead of your parabola looking something like this, it would just be shifted down 2 units. So you'd still have that point 1, 1, 2, 4, etc. just shifted down 2 units. Or I shouldn't say the points 1, 1, and 2, 4. I should say like follows that pattern, because they're not going to be at 1, 1, and 2, 4 anymore. They're going to be at 1 and then -1 and 2, 2, because it's been shifted down 2 units. But if we don't know the pattern of that graph, it's okay, because we can just plug in those x values, anything that's greater than 0. So I can still plug in 0. 0 squared is 0. 0 minus 2 is -2. So when x is 0, my y value is -2. Can I fill in this open circle? No, because this is not a less than or equal to, it's just a less than. So it's going to remain that open dot. I can then plug in 1 if I wanted to. When x is 1, 1 squared is 1. 1 minus 2 is -1. So there's a point here. I can plug in 2 or 3 or whatever. But hopefully you know that pattern. Plugging in 2, that would be 4 minus 2, which is 2. So 1, 2. And so then it would have that parabolic shape, just half of it, but kind of hard to see. But there you go. There's our piecewise function. Again, you could test your knowledge of thinking about, what is my domain? What is my range? Where is it increasing, decreasing, positive, negative, etc., etc.? Okay. Now for the last examples, we're kind of doing the opposite of example 3. In example 3, I gave you the piecewise function and you graphed it. And now I'm going to give you the graph and you're going to come up with that piecewise function. So remember the notation. It's going to be f of x equals and then a curly bracket. We're going to list out the function and then its domain. Function, domain, function, domain. How many functions do we have in this first graph in example 4? We have 2. That's absolutely right. So it's kind of up to you. If you find that writing your domains out first is going to help you, do that. If it's writing the equation out of the line, that function, do that and then do the domain. It's totally up to you. Okay, I know. Let's do us a favor and put an arrow here and put an arrow here. Let's do the same thing for this one down here It's just going to make our life a little bit easier here and here. Okay? And I'll try to be very cognizant of doing that for any kind of quiz or test, is making sure that there are arrows when I want them to be arrows. All right? So here we go. My reading from left to right, remember that's typically how you see your piecewise functions, from left to right, okay? So from left to right, I know that my domain is from negative infinity all the way up to that x value of 2. So that's all the x's less than 2. I am not including 2 because it is a solid, there is an open circle on that first graph. Now I need to figure out what that equation is. Well, I know my y-intercept is 1. That's easy for me to see. And I can also really easily count my slope. That's rise over run. So up 1 and to the left 2, that would give me a negative 1/2 x plus my y-intercept of 1. This is something that you learned back in middle school, so hopefully it's coming back to your brain pretty easily. The second part of my piecewise function is going to have a domain that is x's greater than or equal to 2, because there is a solid dot there. So anything from 2 and then on. I can't easily see my y-intercept, but I can easily see my slope, and it's just positive 1. I'm going up 1 to the right 1, so I know it's x. Now, sometimes I need to do this just because it's how I operate. I know that I can just continue this line if I had to and find my y-intercept, and my y-intercept is negative 1. Okay? If not, you know that you could write it out in y equals mx plus b. You could pick some point on your graph, 3, 2. That would be 2 equals, your slope is 1. That x value is 3 plus b. And you could figure out what that subtracting, that would be negative 1 equals b. Figuring out what that y-intercept is that way. So using a point on the graph and the slope and just solving for that y-intercept. Sometimes that may be easier. Sometimes just following out the graph might be easier too. Just kind of depends. And there we have it. We had just wrote our first piecewise function given a graph. Okay, let's try it again. Looking at this graph, I know some of you may know what this function looks like because it does look like a specific function that we're going to talk about this school year. But right now we're focusing on piecewise. So how many pieces of this graph do you see? I see one piece here, and I see another piece here. Okay, and so that's how we're going to write it. So again, we start with our f of x equals, open up that curly bracket. Again, we only have 2 pieces to our function. The first one is going to have a domain from negative infinity all the way up to negative 5. The second one is going to have a domain from negative 5 all the way to infinity. Now, for the first one, you could say I want the x's less than or equal to negative 5. And for the second one, I could say I want the x's greater than negative 5. And would that make sense for on this graph? It would, because there is a closed dot there. So that could have meant it was closed and then open, or it could have been open and then closed. It could have been an open dot first and then I came back in and closed it in. Or it could have been closed for both. Okay? Typically, we always see it as one open and one closed. It doesn't matter. I would take closed and open, or I will take open and closed. It does not matter. Okay, unless there's a way that we can specifically identify that, or me telling you in words or whatever, it doesn't matter the order that you do that. Or if you want to put them both as closed, that's fine too, I guess. All right, and so now we need to come up with those actual functions. So I want to see if I can figure out my slope and figure out that y-intercept, because we know that these are linear. So the slope for the first half of my graph is I'm rising 1, 2, 3, 4, and I'm running to the left 1, 2, 3. So that's a negative 4/3 x. I can't see on my graph where that's going to be, so I might have to go and do my algebra. Maybe I'll pick this point, which is at -8, comma 5. And I can plug it into that y equals mx plus b again. I know my slope is that -4/3. I know that the y value is 5, the x value is -8. Let me figure out that b value. Now, just by looking at it, could you get a good idea of what that y-intercept should be? Is it going to be something like 2? No. Is it going to be something like -1? No. It's going to be a negative number pretty far down, maybe -5, -6, somewhere around there. And so I can just solve for b here. So -4/3 times -8. Whew, doing some math in my brain. That's going to be a positive, what's 8 times 4? 32. So it'll be 32 over 3. And then, is that right? Do I have a calculator right here? No, I don't. That's okay. 8, 16, yeah, 32. Okay, 32 over 3. And then all I need to do here is subtract. So can we reduce 32 over 3? No, we cannot. So then we subtract that and we get some funky number. I'm going to make this 15 over 3 minus 32 over 3. And so then I'm a little bit nicer to say that that would be a -17 over 3, which is my y-intercept. I know that one was kind of ugly. So there would have been really no way for us to just continue to draw that line and get a really accurate y-intercept. Sorry, that took up a lot of space too. All right. The next one, we're going to do the same thing. Oh, I thought I had to sneeze. So we're going to figure out our slope. So I'm rising 1, 2, 3, 4, running 1, 2, 3. So this time it's a positive 4/3 x. Again, I can't quite see my y-intercept, so I'm going to have to use that algebra skill again. So maybe this time I want to use this point of -5, 1. So I can say y equals mx plus b. I can use 1. I can use my positive 4/3, my -5 plus b. This time we know it's going to be a positive number that's bigger than 5. Okay. So multiplying that, it's going to be 1 equals, that's going to be a -20 over 3, which cannot reduce, plus b. Subtract that over. So I'm sorry, add that over because it's a negative. So this is really 1 plus 20 over 3 equals b, which we know is going to be 23 over 3 equaling b. So that is our y-intercept, plus 23 over 3. Okay. All right. So like I said, that one was a little bit ugly, but doable. Okay. And then the last one, f of x equals. Now this time we do have 3 pieces to that piecewise. Okay. We have this constant, we have part of a parabola, and then we have a linear. So the constant's going to be really easy. What's our function? 3. Done. 3. All right. And then what domain is it on? Well, it's on from -infinity all the way up to -1. So those are x's less than -1. There's an open circle there, so I cannot include that value of -1. The second piece is a quadratic. It is a parabola-shaped graph. I want to make sure that it's hasn't been stretched or compressed, which it hasn't. And we will discuss that more when we get into quadratics. That is unit 4. This parabola has only been shifted up 1 unit. So we know that that's going to be x squared plus 1. Okay, what domain is it on? From -1 less than or equal to x less than 2. Okay, and then the last one, I know my domain is going to be from anything greater than 2. X is greater than 2. My slope on that last part is -1, so it's -x. This is an easy one where I can just kind of go back and figure out my y-intercept. So that would be 4. And there you have it. Okay. And if you, wanted to check yourself, you could plug these 3 things into the calculator and make sure that you're getting a similar graph. But those are correct. And that is it, guys. That is 1.4 piecewise functions.